Okay, hi everybody. Here's the key for problem number 3 and a good solution for this, so enjoy while you can. And just to ensure this is complete dedication to my students, there is a blues game on right now, and I'm making a calculus video. So complete dedication to my students. We're not going to discuss the fact that the Blues are dead last in the standings right now. Anyway, so the goal of this problem is we're going to graph this region that's bounded by these particular curves right here. And I've already done that and highlighted the magic area. Region bounded by y is equal to x squared. Y equals 0, you know it as the x-axis. And x is equal to 2, that vertical line. So this is the green area that we're kind of concerned ourselves with. But the problem is I'm not rotating it around the x-axis. I'm rotating it around the line y is equal to 4. So that's a little bit of a different look than what we did in class. So what we're going to look at is how you get around this. Now, first of all, let's have the conversation about which method to use. We need to know if it's going to be disc or washer. And the way that you can tell the difference is if there's a gap in between your solid and the line of revolution, then you're going to use the washer method. So here's my solid that's going to get rotated around and sort of create this little flat circular surface on top with the red line and kind of like almost an indented bowl, I guess you could say. And what I'm going to get is I'm going to see that right in here, in between my line of rotation and my surface is going to be a gap. So that indicates that I need to use the washer method for sure. So what does the washer method entail? Well, if you remember, we're going to do a definite integral from a to b and have a pi on the outside, and it's going to be big R of x squared minus little r of x. Oopsies, let's get the right case here. And all of this with respect to x. And we're going to do that because we're integrating along a horizontal line. So we're going to do with respect to x to make it easier. So let's see what we can do to figure out what big R and little r should be before we get going here. So big R is going to be the distance between your line of revolution and the furthest curve. Well, in this case, the furthest curve is the x-axis. The furthest curve is the x-axis, and you can see by this orange line I've drawn in, that's what it's going to be. So that's going to be a constant 4. Well, how do I know that's 4? Well, my line of revolution is y is equal to 4. So that's always going to be a constant distance of 4 no matter where I am in my solid. So big R of x is equal to 4. Okay? Now little r of x is going to be this part right here that I just drew in purple, right there. Now it's going to be a lot more challenging to figure out what that is because that's our gap. I've got to take out our gap. And the way to take out the gap and figure out what that is I just want that purple segment. Now, here's how we're going to figure this out. You know that the distance from the line of revolution all the way down to the axis is 4 units. But what we need to do to get this correct distance is we need to take out this green area right here in order to get the right little r. I need to remove this green area. Okay, well, how do I remove that green area? Well, that's easy to do because the green area is represented by the blue curve, y is equal to x squared. So I'm going to say that my little r of x is 4 minus x squared. Now that I've got that, I can go off to the races and do my integral. So let's go ahead and set it up here. It's going to be the definite integral from 0 to 2. There's a pi on the outside. And then I'm going to have my big R squared minus my little r squared. And this is all with respect to x. All right, I'm going to pause it at this point, and I'm going to encourage you to pause the video And when we come back, we'll show you what the answer looks like. All right, now we're back, and you see my final solution here is 224 pi over 15 cubic units for that particular volume. And just kind of quick recap here, because I want to keep this short, get back to that game, you know. So here's the foiled out version right here, and then I combine the like terms, and then I do the antiderivative, so I get 8 third x third minus 1/5 x fifth, evaluated at 0 and 2. Okay, now we can get away with kind of sort of ignoring that 0 just because it's going to make the entire lower limit drop to 0. Had to do that check. So 64 thirds minus 32 fifths, common denominator, and 224 over 15. All right, there you go, folks. Enjoy.